Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0979, indicates a problem with the electrical circuit of Shift Solenoid Valve C in a Honda Civic from 2006 to 2011. This code points specifically to a short circuit issue within the solenoid's wiring, rather than a mechanical fault in the vehicle's transmission system. The shift solenoid valves are crucial components in the automatic transmission, controlling fluid flow to enable smooth gear changes. In this instance, the malfunction has triggered the onboard diagnostic system to log the DTC P0979. Prior to commencing any troubleshooting, it's essential to gather freeze-frame data and perform an onboard snapshot using the Honda Diagnostic System, HDS. The analysis of this data will serve as a basis for understanding the vehicle's performance and may provide insights into the exact moment the fault occurred, facilitating a more efficient troubleshooting process. The DTC P0979 pertains specifically to Shift Solenoid Valve C, which is part of the vehicle's automatic transmission. This solenoid facilitates appropriate fluid flow, allowing the transmission to change gears effectively. Located within the transmission assembly, this solenoid plays a pivotal role in controlling the vehicle's shifting patterns. When the electronic control unit detects an issue with the solenoid, it triggers the DTC as a warning. The underlying problem becomes apparent as the electrical circuit linked to this solenoid faces discrepancies, signaling a short that disrupts its function. It's crucial to understand that such a DTC cannot arise from mechanical faults. It strictly involves electrical circuit failures, which must be diagnosed carefully. The primary causes for the activation of DTC P0979 center around electrical concerns within the vehicle's transmission control module, TCM, and related wiring. A short circuit in the wiring harness, particularly between the shift solenoid and the powertrain control module, PCM, can lead to this DTC being triggered. This can be a result of damaged insulation or improper connections. Another possible cause includes a malfunction within the shift solenoid C itself, potentially leading to it behaving erratically. Additionally, any issues with the PCM connector, which directs signals to the solenoid, may also result in the fault code. Understanding these potential causes fine-tunes the diagnosing process, enabling the mechanic to address the actual issue rather than merely the surface symptoms. When DTC P0979 is present, drivers typically experience noticeable symptoms related to the transmission's performance. A primary symptom includes erratic or improper shifting, meaning the vehicle may have difficulty changing gears smoothly. Additionally, the DTC indicator light on the dashboard will illuminate, alerting the driver to the presence of a fault in the transmission system. This could also manifest as a loss of power or hesitation during acceleration, making the vehicle feel sluggish. Importantly, these symptoms can lead to increased wear on transmission components if not addressed promptly. Moreover, other symptoms may include unusual noise during gear shifts or even an inability to shift into certain gears, particularly if the condition worsens. The initial step in troubleshooting DTC P0979 requires setting the ignition switch to the on position, maintaining it in the on II state without starting the engine. This allows the diagnostic system to power up and communicate with the onboard computer. Prior to initiating any further diagnostics, it's crucial to record all freeze-frame data using the Honda Diagnostic System, HDS. This data captures the vehicle's operating conditions at the time the fault occurred, including engine speed, vehicle speed, and other parameters. This information aids in narrowing down the potential causes of the issue. Additionally, reviewing the general troubleshooting information provided in Honda's guidelines gives insight into common remedies or tests applicable to the DTC and its related circuits, ensuring no preliminary steps are overlooked. Following the recording of freeze data, the next step involves using the Honda Diagnostic System, HDS, to clear the DTC from the vehicle's memory. This action resets the onboard diagnostic system and prepares the vehicle for a road test. It is essential to ensure that the code has been successfully cleared before proceeding to determine if the issue is persistent or if it was a transient fault. Clearing the code allows for a fresh assessment to be made during the subsequent diagnostic tests. After successfully clearing the DTC, it is advisable to conduct a road test, specifically driving the vehicle in third gear with the shift lever in the D position for a minimum of 1 second. This step is critical, as it allows the solenoid to be active and verify if the issue reoccurs during regular driving conditions. After performing the road test, the next procedure involves checking for any pending or confirmed DTCs via the HDS. This step is crucial in determining whether DTC P0979 has returned after the road test and the clearing of the previous code. The HDS will display if the DTC is active, confirmed, or if it is simply a pending code indicating the issue may still exist but hasn't fully registered as a fault yet. If DTC P0979 is indicated, you will proceed to the next set of steps to further diagnose the condition. If not displayed, it guides you toward different troubleshooting methods, implying a resolved condition or possibly an intermittent fault that warrants further inspection of connections and wiring, leading from the solenoid to the PCM. In this pivotal troubleshooting step, you access the HDS and select Shift Solenoid Valve C from the miscellaneous test menu. This test allows you to evaluate the function of the shift solenoid electronically. Listening for a distinct clicking sound from the solenoid during the activation is crucial, as it indicates the solenoid is operational and receiving power. If the click is audible, it suggests that the solenoid is likely receiving the necessary electrical signal to function correctly. Conversely, if no clicking is detected, it leads you down a different diagnostic path, suspecting either a failure within the solenoid itself or issues relating to the electrical connections back to the PCM. This test serves as a diagnostic checkpoint to ascertain whether the solenoid needs replacement or if the wiring harness may be the actual culprit. This troubleshooting step necessitates taking the vehicle for another test drive, maintaining third gear with the shift lever in the D position for at least 1 second, similar to earlier steps. This action re-engages the solenoid function and allows the system to register its operational status once more. Upon completing the drive, you will then monitor the onboard diagnostics, OBD, status using the HDS. It is essential to note whether the HDS reflects a status of failed or passed regarding DTC P0979. The failed status indicates that the issue persists, leading you toward further diagnostic steps, while a passed status indicates that the fault has not been detected under the current conditions. If the system shows an intermittent result, check for any electrical shorts related to the body ground and between the solenoid harness and the PCM. To proceed with the diagnostic steps, turn the ignition switch to the lock position 0, disabling power to the system safely. Next, utilize the HDS to jump the SCS service check signal line, which allows you to bypass certain electrical checks that might interfere with further diagnostics. This action facilitates a deeper examination into the wiring and connections associated with how Shift Solenoid Valve C interacts with the PCM. Jumping the SCS line helps in isolating faults without causing collateral damage or incorrect readings from potential redundant feedback loops within the system. Once set up, You can then move on to inspect connections and continuity to identify any faults that may be present in the electrical circuits. In this step, you will disconnect PCM connector B, which has 44 pins, specifically focusing on terminal B20. This step is critical to ensure safe access to the connection points without risking a short or unintended signal feedback. Once the connector is detached, you will measure the resistance between terminal B20 and the body ground. A resistance reading of less than 12 ohms is ideal and indicates a good connection. Low resistance signifies an intact circuit that can effectively transmit electrical signals necessary for the operation of Shift Solenoid C and other components. If the resistance is greater than or equal to 12 ohms, it indicates a potential issue in the wiring or connection point that must be thoroughly inspected to identify the fault source. After completing repairs or adjustments, it's pivotal to perform a verification process to ensure the issues related to DTC P0979 have been successfully resolved. Start by rechecking the DTC status using the HDS, ensuring that the code does not reappear after your corrective actions. Following this, a test drive is essential. Replicate previous driving conditions to monitor the transmission's performance. Pay attention to any symptoms that previously occurred, such as erratic shifting or warning lights. A successful verification confirms that the shift solenoid and its related wiring are functioning correctly. Documenting this verification helps maintain service records for future reference, ensuring clarity on the repair history. Preventive maintenance is crucial in maintaining transmission health and ensuring systems like the Shift Solenoid Valve C function correctly over time. Regular inspections of wiring and connector points should be a part of routine vehicle maintenance to detect potential wear, corrosion, or damage early. Ensuring that connections are secure minimizes the risk of electrical short circuits that could trigger fault codes such as P0979. It is advisable to maintain cleanliness in the electrical connectors, as dirt and moisture can induce faults in electrical systems. Furthermore, a proactive approach includes periodic diagnostic checks using the HDS to monitor the condition of the electrical circuits associated with the transmission. These practices contribute to extending the lifespan of key components and mitigating unexpected failures. In conclusion, addressing DTC P0979 involves a systematic approach focusing on the electrical integrity of Shift Solenoid Valve C. Understanding the potential causes and symptoms aids in efficiently diagnosing the problem without unnecessary disassembly or parts replacement. Following the structured troubleshooting steps enables technicians to isolate issues, identify faults in the wiring, and assess the functionality of the solenoids accurately. Preventative measures are essential in maintaining the vehicle's transmission system efficiently and minimizing future breakdowns. Adhering to these guidelines not only enhances the longevity of transmission components, but also promotes overall vehicle reliability. By staying informed about these procedures, both technicians and vehicle owners can work collaboratively towards ensuring seamless operation in Honda Civic models from 2006 to 2011. Please like and subscribe to the channel. See you next time.